All right, guys. So we'll continue with exercise 7C, right? So previously we learned how to find the A value when the probability is given, right? So we completed question number 1. Okay, so let's continue with question number 2 as well. Okay, so I want to show you a few important things here, right? Okay, so let's do question number 2, part A. Probability B is less than A is equal to 0.9082. So when you're doing this, okay, so when you're doing this question, I told you some important things that you need to do, right? So when you're finding the A value, or if you're finding the Z value when the probability is given, I told you the first thing you need to decide is you have to decide about the sign of the A value even before you start the sum. So you need to decide whether this A is a positive A or a negative A. So you have to decide that even before you start. So what do? I told you to go for a diagram, do a small trial. Okay, do a small trial. So this is the mean 0. So let's try first with A positive and let's try with A negative. Okay, so I'll try with A positive first. I marked A here, guys. Okay, so this is on the positive side because you can see this is in front of 0. And then this to which area, to which side do we shade? Is that is less than, right? So less than means you are shading behind the line, right? Are you with me? That is less than means you are shading behind the line. So that means I had to shade the area behind the line, this area. Okay, so is it less than A? I shade the area behind the line. And you can clearly see the way I have shaded this. This is the area that's smaller than half or bigger than half. You can see this is covering half the area and there's another portion here, right? So it's more than half the area, right? This is the area that's more than 0.5 because you have covered more than 0.5. Can you see? So then does it correspond to 0.9082? Yeah, it can, right? Because 0.9082 is the area bigger than half. And you can see the positive A here is covering an area bigger than half for the less than side. Okay, so that's all you need to check. Okay, so you have to check if this is bigger than half or smaller than half. So this is bigger than half. Okay. So if it is bigger than 0.5, you're shading a large portion of your diagram, more than half the area. So then you can see this makes sense. So if this makes sense, what does it tell you? Your A value is positive. Okay, my A value is positive. So that means I can directly, we can go for it, right? Okay, so let's directly go for it. Z less than A. So you can see I have probability Z less than A is 0.9082. And you can see this is the format that I want, right? So I told you if you are using the normal distribution table, number one, the table gives you the area behind the line, behind the positive value. So here this is less than. That's what we want, right? And it's behind A. So this is basically pi A, right? You get it? Do you recall I gave you this notation phi? If you are having the area behind, so this is exactly what we want. This is the format that you can directly use the table. So let's go for the table and search for 0.9082. Okay, so where do we get it? 0.9082. Yeah, here you can see guys, 0.9082. So that comes with the A value 1.33. Can you see? 0.9082. That's it then. Okay, so all right. So this is going to be A is equal to 1.33. That's it. Positive way. That's all. All right, guys. All right, guys. So let's move on to the next part. Probability Z greater than A is 0.0314. Okay. So again, let's do the first thing, right? So let's draw the diagram and decide whether A is positive or negative. Okay. So shall we do that? This is the mean 0. So let's try. Okay. So I'm going to first think A as positive. If that doesn't work, then I'll cut the diagram and try the other side because it has to work in one of the two sides. Okay, now to which direction are we shading? So now these are the important things to note. Number one is that greater than. So greater than means you are going to shade not behind, you are going to shade in front. And you see, is that greater than means you have to shade the area in front. Okay, so that's important. Okay, always make sure you correctly shade the region. Is it greater than 0.0314? So what do you think about this area? Is this the area bigger than half or smaller than half? You can see this is smaller than half, right? This is the area that is smaller than half. That means the area area smaller than 0.5 means 0.0314 only shades a small region. It doesn't shade more than half. Now you can see here in this shade part that I have shaded, I have I shaded more than half the area? No, right? Now you know this is half the area. But have I shaded more than half or less than half? Clearly, this what I have shaded here is less than half. Right, guys? So then you can see this makes sense. This makes sense, which means what? That means what we've done here is correct. So which means the A value is positive. Okay, so your A value is positive. Okay, so we can go ahead. So let's go ahead. A value is positive. So now let's use the rules. Now, you know, in order to do this sum, you can't have, you can't work it z greater than, right? We need to convert it to z less than, right? So when you have z greater than, I think I gave you the rules of conversion, right? I gave you all these rules to convert. So z greater than a is, in other words, 1 minus probability z less than a. So or less than or equal a. So anything. So let's convert it. So this is 1 minus probability z is less than a or less than or equal a. So now you can make this guy the subject. This is a negative probability. Take it here, take this number here. Okay. So you get here 1 minus 0.0314 is equal to the probability z less than a. Agreed, guys? So how much is the answer? All right, so we have 0.9686. Okay, equals the probability z less than a. So probability z less than a means this is the phi a, right? You don't need to use this notation, but actually it's good to know it, right? So z less than means the phi a, so 0.9686. So now we are ready to go for the table. So let's go for the table and search for it 0.9686. Okay, where is it? 0.9686. Guys, can you see this one? 0.9686 over here. The cursor, you can see it's at 1.86. All right. 0.9686, the corresponding A value is 1.86. All right. So which means your A answer equals to 1.86. All right. Okay, guys, so we'll move on to part C. So here part C and D and G and H. Okay, so here I have to show you a little bit of a new technique. So I think at this point, I believe that you all are now capable of deciding whether A is positive or negative, and also that you guys now know how to convert whatever they've given you into the format you require. So I've given you these 4 rules, so you know how to convert everything to Z less than A, right? Okay, so now let's see the problems we face in part C and D. Okay, so in part C and D, first thing is let's do the usual thing. What's the usual thing? First, let's decide whether A is positive or negative. So that's number one. First, let's decide on that. Okay. So when okay, so here you have 0. I'll mark A here. So let me try. Okay, I'll try with A here. If it doesn't work, I'll mark A on the negative side because it has to work either on the positive side or the negative side. Okay, so to which direction do I shade? They say Z greater than. So Z greater than A means I'm supposed to shade to the greater than side. Is that okay? I'm supposed to shade to the greater than side. So Z greater than A and this area. So if you check on this area, this is less than half, right? So if this is less than half, guys, does this correspond to area that's less than half? You can see it does, right? Because it doesn't cover more than half the area. So this works. 0.15. This is a small area. It doesn't cover more than half the area. So it works, right? So if that works, what does that tell you? It means the place where you thought that you thought A is positive, and that's correct. Okay, so that's correct. So here, which means A is positive. Okay, your A value is positive. Okay. All right. So now, guys, let's do the sum. Now, if you go do this in the traditional way, let me show you. Okay, so what do we usually do? So when we are trying to use the normal table, you saw that the table that we were working with, we always work with the areas behind, right? Not z greater than, so we convert to less than. So I gave you the conversion, z greater than is equal to 1 minus probability z less than, right? That was our conversion table. So 1 minus probability z less than a. And then guys, you can get the answer, right? 1 minus 0.15 is equal to probability V less than A. 1 minus 0.15 is 0.85. Probability V less than A. That's 5A is 0.85. Are you guys with me? Okay. So now what's the issue? Okay. So let's go to the table. Now, here I have to find the A value or the Z value when the area is 0.85. Okay. So let's go to the table. Okay, guys. So do you see the problem now? I want to search for 0.85. So here 0.7, 0.81, 82, 83, 84. Let me go here. Do you see the problem here? Okay, then again 84, so 84, 85, 8508. Can you guys see now in all the sums that we did previously, you saw that we were able to find the value exactly from this table. We didn't have trouble, right? We really did not have trouble. So in all the questions we did before, you saw that we were able to get the numbers really well. And also, now you can see in this table, the values are mostly given to 4 decimals, right? So everything in the areas, 5Z values are given to 4 decimals. And you can see clearly here, you don't have any 5Z value that goes with these kinds of, how do you say, 2 decimals, like where you have these kinds of decimals. Okay, guys. So in this case, I want to show you that you actually have, okay, in this formula book, you actually have 2 normal distributions. Okay, so this is the first table. If you go to the next page, right, and even in the behind your S1 textbook, you will see there are actually 2 normal distributions. This one is the large one, and there is again another smaller one. Guys, do you see this? This is the second table. So if you check the very next page, okay, you will find this. Okay, so percentage points of the normal distribution. So guys, what is special about this table? Okay, so look at this. In this table, okay, in this table, the values of Z in the table are those with a random variable, okay, which exceeds with probability P. Can you guys see? Now, in this particular table, okay, in this particular table, they are giving you, okay, guys, pay close attention to this. In this table, okay, they are giving you the area. Can you guys see? They are giving you the area. Is that greater than Z? Can you guys see? Okay, the area that they're talking here is probability Z greater than Z, or the 1 minus 5Z area is what they have given you. So basically, if you have a Z value over here, guys, if this is your Z value, okay, and you mark this, then probability Z greater than Z. This is the area that they have given you. Can you see? So the other end of the tail. Now in the previous normal distribution, the other in the previous page, the big table. In the big table, when you were working with the big table, you saw that they gave you the area, okay, behind this line, right? They gave you the area to this side, this area, right? So this is what we were working with in the previous table. Okay, there you had a positive A value and you had the area behind. But in this second table, they give you you have a positive Z value. Again, it's a positive Z value, but the area is given to the front side, not to the back. Can you guys understand? So this is what's important here. Okay, so in this table, you had a positive Z value and your area, this was the 5Z area, right? 5Z is the area. So you had the area behind the graph. Now in this table, In the new table, you have the area in front. So it's the 1 minus 5z area. Because you remember 5z is the area behind the line. So 1 minus 5z is the area in front of the line. So this is the new table. Okay, this is the previous table. Okay, and this is for the new table. So this is that's really important. This is for concerning this table. So this is really important that you understand how to work with this guy. Okay, so you can see here, for example, let me show you. Let me explain to you what this means. Okay, what does this mean? What does this mean, guys? So if I show you, okay, so here the Z value is 0.8416. Can you see? All the Z values they've given here are positive. Okay, so can you see in this case the Z value is the second column. Okay, again be cautious. I think the difference between the other table and this table, in the other table the Z value was given first, the P value was given second, and here it's not just the P value, it's the 1 minus 5Z value, right? Can you see the P here is the 1 minus 5Z, which means the area in front. Okay, can you see? Okay, so the Z value is 0.8416. Okay, so that's the positive Z value. So this is your Z value 0.8416, and what area do we mark? You need to take the area 1 minus 5Z means the area in front. And what is the area in front? How much is it? The area in front is 0.2. Can you see, guys? The area in front is 0.2. So basically, in other words, the probability is that greater than 0.8416 is equal to 0.2. That's how we work with this table. Can you guys see? So it's really important that you understand how to work with this second table. Okay, so what they say here is the probability that your Z value is greater than 0.8416 is this 0.2. And you can see, guys, in the second table, all these probability values, do you see that they are all, do you see that you are working with like two decimals, 0.1, 0.2, 0.05. So these are like, how do you say? So you work with some nice probability values, right? Because in the previous table, the probabilities you were working were 4 decimal probabilities. Do you see the difference in the previous table and this table? In the previous table, your Z value was 2 dp and your probability was 4 dp. Now in this table, can you see your probability is like 2 dp. You have nice probability values, 0.1, 0.2, 0.3. So you have good, nice, small looking probability values, and your Z value is 4 decimal. Okay, guys, so that's the difference between the table. And the previous table gave you the area behind the Z value. In the second table, they give you the area in front of the Z value, in front of the positive Z value. Okay, so that's the main difference. Okay, so you need to know when to use which table. Okay, so let's go back to our sum. Okay, guys, so this is moving back to question number 2, part 3. Okay, so we determined that A is positive, right? I think this is what we were in the middle of. I came over here and I was explaining you the table with some examples. Okay, this was an example. Coming back over here, we found, because the first thing when you now over here, when you're finding the A value, before you do anything else, the first thing is to see whether it's positive or negative. And you saw that I did the working and I showed that A is positive. Okay. So that working, I showed it just a few minutes before I came here. A is positive. So if A is positive, now let's draw the diagram. This is 0. A is positive. And the area in front is 0.15. So the area in front means it's the 1 minus 5 A area. Right, guys? So basically now you know this second table. This second table that you are using. Okay, so by the way, what is the motivation to use this table? The reason I'm going for the second table is just because of this probability value. Okay, the reason that I'm going for the second table is because of this area 0.15, because I know that I can't find an area of 0.15, or the behind area is 0.85. I can't find a value of 0.85 from the previous table, right? You saw that you didn't get 0.85. But in this table, you can see we can find 0.15. Can you see, guys, here 0.15? It's possible to find the area in front, right? So I can find it here. So 0.15 is the area in front, and the corresponding Z value is 1.0364. So that's your answer, guys. So our A value here is 1.0364. We know the A is positive, so that's it. We know our A value is positive, right? So the important thing in this table, the second table is that not going to keep the probability to Z less than A. So when you're using the second table, the format, when using the second table, we need to keep the format probability Z is greater than. Can you see? So this is the format for the second table. But if you are using the first table, if you are using the first table, the format is to keep probability Z is smaller than. The first table is to find the area behind. The second table is to find the area in front. In both the cases, A should be positive. Okay. All of these are working if A is positive. So that is important. A has to be positive. If A is positive, when you are using the second table, okay, you have to go for probability Z greater than A. When you're using the first table, you have to go for probability Z is less than A. Can you understand? So you can see here I'm going with Z greater than A. Okay, and I can immediately find the answer. So depending on the table, you need to decide whether you are going for the less than area or the greater than area. Okay, guys, so that's kind of like the summary. Let's do some more questions. Okay, guys, so I'm done with part C now. Let's go to part D. Probability Z greater than A is 0.95. Okay, so how do we work with the probability Z greater than A equal 0.95? Okay, so what's the first thing we do? I'll do it over here. So what's the first thing we do? We need to determine whether the A value is positive or negative, right? The first thing is to determine whether A is positive or negative. So let's draw the graph. Draw the normal distribution. And you mark your A value. So I'll mark A as positive first. Okay, so let's try with this. Now, which side do I need to shade? This is Z is greater than, right? Here we have Z greater than. So greater than means I have to shade to the the area in front. So I have to go for the area in front. So this is the area in front. So now you have to ask yourself the question. Okay, so now what's the area here? 0.95. Is this more than half or less than half? 0.95 is more than half, right? This is more than 0.5. Now you have to ask yourself the question, is this area, the area that I colored, is it more than half? Do you think this area is more than half? Definitely not, right? You can see this area I have colored is less than half, right? The area that I have colored is less than half the area, but it doesn't correspond to 0.9. So what does it mean? It means this diagram is wrong. Okay, so that means the A value, the position of the A value is wrong. So let's draw another diagram. And this time we can put A not in front, but at the back, which means my A value is negative. Which means my A value is negative. Are you with me? And to which direction do I shade? Z is greater than. Greater than means you have to shade in front, guys. In front of the line. You have to shade in front of the line. So shading in front of the line. Okay, because it is Z greater than. You have to shade in front. And then 0.95. Does it look like it can correspond to 0.95? It does, right? Because it's more than half. 0.95. Okay, that's fine. This area looks okay for to be I mean, it looks correct, right? It's more than half the area. So what does that tell you? End of the day. So what did we identify? We identified that our A value is negative. Okay, so end of the day, when you give your answer for A is a negative answer. Got it? A is a negative answer. Okay. Okay, now let's go for using the table. Okay, guys, now if you, I think you can see the moment you look at these probabilities. Okay, so let me show you this. So when you're looking at these probabilities, guys, okay, looking back over here. Okay, looking back at these sums, okay, coming back to exercise 7, just look at this, guys. Do you see that these probabilities, now you can see immediately by looking at these sums, for which particular sums you use the first table and for which sums you use the second table. You can see if your probability values are like this to 4 dp, you use the first table. So this entire first question is from the first table. And guys, here second question part A, you can see the probability is 4 dp, 0.9082. Here, this is also 0.0314. So these kinds of probabilities, you work with the first table. But can you see in part C, part D, your probability values are 2 dp, 0.15, 0.95. Can you see? So these kinds of questions you can work with in the second table. Okay. Again, part E and part F, you can see here this probability is 4 dp, 0.3554, 0.4946. So these kinds of questions you can work with the first table. And again, part G and H, do you see the probabilities? You have 0.8, a probability with 2D, just 2 dp. Can you see 0.8 and here 0.4? So when you see these kinds of probabilities, you should know that immediately you should go for the other table, the second table. Are you with me? So these are the 4 questions I have shared are the questions you need to work with using the second table. Okay, so when you have decimals with 4 dp, you can work with the first table. Okay, guys, otherwise you can use the first table for this also, but then you are going to take a value as close as possible, not the exact figure, but they've given you another table so that you can do these sums accurately. Okay, guys, so let's get the advantage of it. Okay, so let's go to the sum. So I'm going to work with the second table. So how am I working with the second table now? Okay, so coming back. Okay, so now, even in the second table, we need to have positive Z values, right? Not negative Z values. The second table also works with positive Z values. So rewriting the sum, I have probability Z is greater than minus A is 0.95, right? Because I identified the A value is negative. So this is not a positive A value. The original sum is a negative A value. Okay, so then even this table doesn't work with negative values. It only works for positive A values. So shall we convert? I've given you the method of converting negatives to positive. How do you convert? Is it the inequality mark is gonna flip, right? Greater than becomes less than, minus A becomes plus A. Do you remember? Do you recall? So this is what we did in the previous work, right? I told you how to convert a negative A value to the positive by using the symmetry of the graph. This is basically by using the symmetry, right? So I gave you the rule. Z greater than minus A is equal to probability Z. The mark is flipped, the negative A becomes positive A. So this is work we did in the previous section, right? So you directly, you can do the conversion. Okay, so then this immediately negative A becomes positive A. So now we are working with the area behind. Okay, guys, but to use this table, what do we need? We need the probability of Z is, we need Z greater than Z to use this table. I don't want to work with Z less than. I want to work with Z greater than. Okay, the second table is in that format, right? Do you see? So how do I convert to that format? Z less than A, you can convert to, when you do 1 minus probability Z greater than A. Do you recall what I'm talking about? So if you have, this is the simple A. So this is the probability Z is less than A. So if you do 1 minus, you get the probability Z is greater than it. So 1 minus probability Z, sorry. Yeah. So from 1, the total area 1, if you subtract the area in front, they said greater than A area, you get the probability Z is less than A, right? Let me write that here as well. So you can write probability Z less than A is equal to 1 minus probability Z greater than A. Right, guys? This is a rearrangement of a classic formula, right? What's the normal equation we use? I think I gave you this equation, right? Probability Z less than A is 1 minus probability Z greater than A. This equation was given to you, right? I think you are familiar with this. Z less than A is 1 minus probability Z greater than A. Okay. I'm writing the same thing, right? I think I gave it to you the other side, right? The equation we learned previously was Z greater than A is 1 minus probability Z less than. Yeah, okay, so I think this is the equation we learned, right? This is one of the main equations, I think, right? In the previous section, this was one of the main equations. Z greater than A is 1 minus probability Z less than A. So what I do here is I am rearranging the same guy. Okay, so this was one of your main equations. So I think this is something you need to remember. You should definitely remember. So when I rearrange the same guy, I get here probability is that, sorry, am I writing the same thing again? Okay, now I'm going in the correct direction. So here probability Z less than A comes here, right? So I take this person to the other to the left side, and I have 1 minus I take this guy. Okay, I take this guy to the other side. Okay, guys, so it's basically the same equation. That the main equation you use, I'm just rearranging. Okay, so that's all. Okay, so then over here, the reason that I'm going with this conversion is for Z less than A, because I want to get the area in front, because this table only works for Z greater than. Okay, so let's convert. 1 minus probability Z less than A is, wow, Z less than A is 1 minus probability Z greater than A. Okay, guys, so let's now work and get the area. So 1 minus 0.95 is equal to probability Z greater than. 1 minus 0.95 is 0.05, right, guys? Probability Z is greater than it. So this table is working very well with this. This table is built for Z greater than A probability. And now we know we have converted our A value to positive also, and we have Z greater than also. So we can now use this table, right? Both conditions are satisfied to use the table. A is positive and you have Z greater than. So do I have a value here? The probability value. The P value is 0.05. Do I have such a value? Yeah, 0.05. Can you see? The probability value is 0.05. So what's the corresponding Z value? 1.6449. Can you see? So for the probability value 0.05, the corresponding Z value is 1.449, 1.6449. So then that's the answer here. So your A value is 1.6449. However, that's not the final answer, right? What's your final answer? You know your A value is negative. So coming back to the sum, is it greater than A equals 0.95? So come back to the sum. You write this part again and write here the A value is minus 1.6449, because this is the original sum. A was not in front, A was at the back. Okay, so you need to write the answer as a negative. So this is the final answer. Okay, so you need to write this down. Write the sum again and give the answer for this sum. Because you can see we found the A value by converting to a different sum, right? We kind of like did a small conversion. Okay, so this is the answer that you require. So guys, I think that might have been a little bit tough on you, right? So I think I did over explain it. So let me give you a quick, just another quick example of that to finish it off. Let's do one more. Probability is it? So this is just an example, okay? Not a question in the book. So let's just do one more really fast. Is it greater than A? Let's go that it's equal to 0.99. Let's go with this. All right, guys. So let's do this quickly. Okay, so how do we do this? What's the first thing you do? So let's do a quick recap. So you mark the zero value. So let's first assume where A is, right? So I'm going to think A is positive. Which area do I shade? Here it is, that is greater than. So greater than means you have to shade the area. You have to shade the area in front. You have to shade the area in front. Now ask yourself the question, is it more than half or less than half? You know it's more than half. So which means is this diagram correct? The area that I've shaded here, does it correspond to 0.99? Definitely not. So this is wrong. Okay, so this diagram is wrong. Okay, so we can't go with this. So let's go for another diagram, which means this obviously tells you that your A value is negative. So you don't even need to draw another diagram, because if the first one is wrong, it automatically tells you that the other one should be the A value is negative. Okay, you don't need to keep drawing it. So is that greater than means you shade the area in front and you have shaded more than half the area. So this looks okay, right? This looks okay, which means what? Which means that your A value is negative. Okay, so your A value is negative. So we write in the sum now. What's our sum? Probability Z is greater than negative A is 0.99. Okay, guys. So you know what's the biggest issue in using the tables? For to use any one of the two tables, I want to make sure my A value is positive. Regardless whether it's the first table or the second table, A has to be positive. So how do I convert the negative A to positive way? So you know the rule, directly do the conversion. Z less than becomes greater than becomes less than, minus becomes plus. That's all. Right? I gave you the rule before. Okay, so this is it, the conversion. Okay, these were I explained this very clearly in the previous part. Is it greater than minus a is exactly the same as probability z. Flip the sign, flip the inequality, and flip the positive negative sign. Here it's negative, it becomes positive. So now I have converted my negative way to positive way. Okay, guys. I think you can see now here is that less than a means you can work with the first table. But in the first table, you will not find 0.99 exactly because it's too deep. Okay, you will find values close to 0.99 in the first table, but not exactly. So that's where the second table comes in. In the second table, though, the areas are going with Z greater than. So how do you convert to Z greater than? How do you convert? It's one really small step. Z less than is 1 minus probability Z greater than. That's all. That's it, guys. This is the way you convert. Z probability Z less than A is equal to 1 minus probability Z greater than A. That's all. Do the conversion. So this is equal to 0.99. Now do the subtraction. 1 minus 0.99 is equal to probability Z is greater than. 1 minus 0.99 is 0.01. Agreed? And now you know the A value is positive, it's a greater than. So if the A is positive and greater than means you go with the second table. So in the second table, do you have such a person where the is it greater than area is 0.01? Yeah, we have, right? Can you see? Probability is 0.01. The corresponding Z value is 2.3263. Can you guys see? So that's it. So my A value is 2.3263. That's the A value. Coming back to our sum. So what was our sum? Our sum was given probability is greater than A is 0.99. This was the sum. And you identified here A is negative. We identified at the very beginning. So A, the value that we require, A equals minus 2.3263. So this is the A value you require. Okay, guys? Okay, guys, so that's done. Let's move on to part E. Probability Z between 0 to A. Probability Z between 0 and A is 0.3554. Let's do that. Probability Z between 0 to A is 0.3554. That's part E. Okay, guys. So let's draw a diagram here. You don't need a diagram also, but actually when you see this, okay, I think you can clearly see here the A is positive, right? I mean, there's no argument because over here, Z equals 0 is this, right? And V is bigger than 0 and smaller than it. So basically this area. Are you with me, guys? So basically they're talking about this area, right? Because the area between 0 and A, and that area is 0.3554. You don't even need to, now you, of course you can use this formula, okay? But I mean, you can use it or you can use your common sense. So how do you use your common sense? Now, you know, first thing is, you know, you're using the first table, right? You know, you're now not going for the second table because this kind of probability values you won't get in the second table. Second table has probability values of 1 dp or 2 dps, never 4 dps. Okay, so then, you know, you're using the first table. The first table, in order to find the area, you need to have the area is at less than a, right? You need the complete area behind it in order to use the first table. So guys, you know that this area is 0.5, right? So if I want to find the probability Z is less than A, what do I need to do here? I take 0.3554 and I can just add half, right? Because when I add this half area to 0.3554, I get the complete area behind it. Do you get it? This is one way of doing it. So there are many ways of doing this. 0.8554. Okay, or else if you want to go with the theoretical method, guys, it's entirely up to you how you do this, okay? I can do this by using this theory method. This method I gave you. Probability Z is between A and B. You can rewrite it like this, right? Probability Z less than A minus probability Z less than 0. Can you guys see? So probability Z less than A we don't know, but probability Z less than 0, you know, it's given in the table. right, in the first table. So if you go for probability z less than 0, right guys, this table, z less than 0 is this one, right? Because this table gives the area behind. Here is the z0 and it's 0.5. So makes sense, right? So this is 0.5, this area. So again, you end up coming back to the same place. Okay, so I think maybe using your common sense is easier. Okay, so what's the A value? End of the day. How do you get your A value? We know our A value is positive, so nothing to convert. How do you get the A value? Go to the table, get the area behind is 0.8554. Do we have that? 0.8554. Here, guys, we have it perfectly. 0.8554. The A value is 1.06. All right, so that's it. Okay, guys, moving on to part F. I think you can again see it's very similar, right, to part E. So Z between 0 and clearly A has to be positive because Z is smaller than, greater than 0 and smaller than A means you can't have A on the other side. So this area is 0.4946. Okay. Okay, so how do you get the area? I know I have to go for the second table. Looking at this probability, you know that you can't go with the second table. You have to go with the first. And if you're going with the first, I need the complete area behind A. How do I get the complete area behind A? I take 0.5 and add it to 0.4946. All right, guys. So probability Z is less than A equals to 0.9946. All right, guys. So how much is it? 0.9946. Let's search in the table. 0.9946. Can you see guys over here? This one, right? 2.55. So A value is 2.55. Okay, guys, that's it. Okay, so then we'll move to the last two parts. Okay, this guy. Probability Z is greater than minus A and smaller than plus A is 0.8. So guys, the moment you look at this probability 0.8, you know you won't find such probabilities in the first table. Because when you see probability values to 1 dp or 2 dp, you mostly find them in the second table. Okay, you don't find them in the first table. So definitely we need to look at the second table, and you know the second table is only giving you the area in front of the positive way. Is that greater than A area? So now you need to do something to convert this to is that greater than A. Okay, guys, so let's do the sum part G. Probability Z is bigger than minus A, smaller than plus A is 0.8. So you know what, guys? I know I have to go for the second table, right? We know we are going for the second table. So the easiest way to do this, draw the diagram. This is 0. And you know this is minus A. And you know this is plus A. Right, guys? And you know the area in between is 0.8. Are you with me? This area is 0.8. Now, if I want to use the second table, I need the probability Z is greater than it. This is the format for the second table. So can't I easily get this area without doing any I mean, I don't need to write any formulas here, right? We can use our common sense. We can see this is a symmetric graph and the total area under the graph is 1. So if this is 0.8, guys, 1 minus 0.8 is 0.2. That's the rest of the area. And 0.2, when you divide by 2, you get each side as 0.1. Do you see? Isn't this a lot easier? So the area in between, because minus A and plus A is symmetric. Subtract it from 1, 0.2 is the area on both the tails. Divide by 2 to get each tail. So basically, probability Z greater than A here is 0.1. Convert the sum. And when I have it like this, I can immediately use the second table now. Okay, so I'm immediately going to go for the second table. Is it greater than A? Because second table is for is it greater than A. So is it greater than A is 0.1. So this is 0.1. Here, guys, 0.1 is the probability. Here, the probability value is the first column. Is that is the second column. Okay. So probability 0.1 is that value 1.2816. Okay, so here the A value 1.2816. Here we'll give the positive way because you have the positive 1.2816 here and negative 1.2816 here. So we'll just give the A value. Okay, guys? I think this is clear now, right? And then, guys, the last part, probability Z is greater than minus A to plus A is 0.4. Okay, so let's make the decision. Last part, probability Z greater than minus A, smaller than plus A is 0.4. So again, let's draw the normal distribution. So here you have minus A, here you have plus A. And the area in between is 0.4. Okay, so you know what you should do here, right? So let's subtract the area 0.4 from 1. 1 minus 0.4 is 0.6, right? And then that 0.6 is the two tail areas. Let's divide by 2. 0.6 divided by 2 is 0.3 on either side. So then you have a decision now. You can either go with Z smaller than positive way or you can go with probability Z greater than positive way. Because if you use Z smaller than positive way, then you go with the first table. If you go with probability Z greater than positive way, you go with the second table. Now depending, now you can see if you go Z is smaller than positive way, guys, it's this area. Z smaller than positive way is 0.4 plus 0.3, 0.7. Do you see? But I think you can see if you try to use the first table, you don't find such a good area, 0.7. You don't find such an area in the first table because the first table, the probabilities are given to 4 decimals. You won't find such a value in the first table. So you can only come to a close value to this. So instead of going with this, let's go with this. The other one. It said greater than A, the area in front of A is 0.3. So we can go with that and we can easily find the exact answer without doing any approximation. All right, so is it greater than A is the format for the second table. So going to the second table, is it greater than A is 0.3. Do I have a probability P 0.3? Yes, yes. Probability value is 0.3. The Z value is 0.5244. Okay, so that's it then. So your A value is 0.5244. Okay, guys, so that's okay, so that's how that's done. Okay. All right. So I think I believe that now you guys should be really good in when they give you the probability values, you need to be able to find the corresponding Z values, and you have two tables to do that. Depending on the probability values they give, you need to decide whether you are going with the first table, the Z less than A table, or whether you are going with the second table, which is Z greater than A table. Okay, so make sure you are well practiced with exercise 7B and exercise 7C before you even think of attempting the next set of questions, because everything after this is following from these two exercises, right? So mastering these two exercises is extremely important. So that's the base of this entire lesson. Okay, all the questions are built by using these techniques. Okay, so if you are good with these techniques, you should be able to do the normal distribution sum. Okay, guys. So we'll go for the next part now.